Have you ever wondered why trend modeling and forecasting are crucial in time series analysis? Imagine you're running a business and you're tracking your sales over time. You start to notice that there are patterns, like sales increasing during the holiday season or dipping in the middle of the year. This is where trend modeling comes in. It helps us identify these patterns over a specific period. Now, suppose you want to predict how your sales will look in the future based on your past and present data. This is what we call forecasting. It's a bit like having a crystal ball, but instead of magic, we use statistics. For example, if you know your sales have been steadily increasing over the past 5 years, you can forecast that this trend will continue and plan your business strategies accordingly. So, trend modeling and forecasting are not just statistical jargon. They are tools that help us make sense of data and predict future trends. Now, let's delve into how we can fit a least squares line to a time series. First off, what exactly is a least squares line? It's a statistical method that attempts to find the line of best fit by minimizing the sum of the squares of the residuals. In simpler terms, it's a line that best represents the relationship between your variables. And a time series? It's a sequence of data points, typically consisting of successive measurements made over a time interval. Time series analysis is often used to track a variable's movement, like stock prices or weather patterns over time. Now let's get to the fitting process. The first step is gathering your data. This could be anything from monthly sales figures to daily temperature readings. Just remember, the more data points, the better your model will be. Next, we clean the data. This means removing any outliers or missing values that could skew our results. It's like tidying up your room before you start studying. It makes the whole process smoother. Now we're ready to choose our model. For this, we're going with the least squares method. Why, you ask? Because it's a straightforward and effective way to find the line of best fit. Once we've chosen our model, it's time to fit it to our data. This involves a bit of number crunching, but don't worry, there are plenty of software options out there that can do the heavy lifting for us. The final step is validating our model. This means checking how well our line of best fit matches up with the actual data. If the fit is good, we can use our model to make predictions about future data points. Let's use an example. Say we're tracking the monthly sales of a particular product. We gather our data, clean it, choose the least squares method, fit our model, and then validate it. If all goes well, we now have a reliable model that can help us forecast future sales. Fitting a least squares line to a time series might seem complex, but when broken down into steps, it becomes a manageable and useful process. However, like all models, fitting a least squares line to a time series has its limitations. Linear models, as the name suggests, assume a linear relationship between time and the variable we're studying. But the real world is often not so simple. For instance, consider the spread of a viral outbreak. It doesn't grow in a straight line, but rather, it tends to explode exponentially, a pattern a linear model would fail to capture. Forecasting, too, comes with its own set of challenges. It's based on the idea that the future will behave like the past. But as we all know, tomorrow can be full of surprises. Take the stock market, for example. No matter how good our model, it can't predict a sudden market crash or boom. Despite these limitations, linear models and forecasting remain valuable tools in time series analysis. Let's quickly recap what we've learned. We started by emphasizing the significance of trend modeling and forecasting. It's an essential tool that gives us the power to understand the past and predict the future, making it crucial in numerous fields, from finance to meteorology. Next, we delved into the process of fitting a least squares line to a time series. This is a method that minimizes the sum of the square differences between observed and estimated values, creating a line that best fits our data. It's a practical and straightforward method for capturing trends over time. But we also noted that it's not without its limitations. Linear models assume a constant rate of change, which isn't always the case. Plus, forecasting is by nature imperfect, as it's based on past